A pleasant greetings to all. In this video, I am going to explain how the state model is derived from the transfer function. Consider a problem. Obtain the state model for the system described by the transfer function y of s divided by u of s equal to minus 2s plus 1 divided by s cube plus 5s square plus 3s plus 1. Once again, I am rewriting the equation as y of s by u of s, that is equal to, I have to rewrite this equation as y of s divided by x1 of s into x1 of s divided by u of s, that is equal to 2 minus 2s plus 1 divided by s cube plus 5s square plus 3s plus 1. First, I am going to write x1 of s divided by u of s. U of s is in the denominator, so you have to take the denominator term. So 1 divided by s cube plus 5s square plus 3s plus 1. Then you have to cross multiply this equation. We will get s cube plus 5s square plus 3s plus 1 into x1 of s, that is equal to u of s. Now expand this equation. We will get s cube into x1 of s plus 5s square into x1 of s plus 3s into x1 of s plus x1 of s equal to u of s. On taking Laplace inverse of the above equation, Laplace inverse Laplace transform of the above equation, we will get x1 triple dot. What is x1 triple dot? That is d square x1 by dt square. Then 5 into x1 double dot plus 3 into x1 dot plus x1, that is equal to u. Now we have to define the state variables. The state variables are 3, that is x1, x2 and x3. First I have to assign x1 dot equal to x2. Then x1 double dot equal to x2 dot equal to x3. After that, take differentiation once again. x1 triple dot equal to x2 double dot equal to x3 dot. Now I have to substitute these values in the equation number 1. So what is x1 triple dot? That is x3 dot plus 5 into x1 double dot is x3 plus x1 dot equal to x2 plus x1, that is equal to u. From this equation, what is x3 dot? x3 dot equal to minus x1 minus 3x2 minus 5x3 plus u. And already we got the answer for x1 dot, then x2 dot also. This is the third value, x3 dot. Now we have to form the state model. Now we have to form the state model in the matrix form. So in a matrix form, in the left hand side, you have to write the dot values. So x1 dot, x2 dot, x3 dot in the left hand side. So right hand side, you have to write, first you have to write the A matrix. So A into x1, x1, x2, x3 plus B into U. So here you have to write the values. So first, what is the value? x1 dot. So x1 dot equal to what? x2. Put 1 in x2. Remaining values are 0. And What is x2 dot? x2 dot is x3. Instead of x3, put x1 and remaining values are set to 0. What is x3 dot? Minus 1, minus 3, minus 5. So first x1 dot, there is no u term, put 0. x2 dot also, there is no u term, again put to 0. But x3 dot, we are having u term, put 1. So this is the state equation. Next, I am going to find out the output equation. So to find out the output equation, next you have to take y of s by x1 of s. Now y of s is in the denominator, so you have to consider the denominator term. So y of s is equal to y of s by x1 of s equal to minus 2s plus 1. Here also we have to cross multiply this equation. So y of s is equal to what? Minus 2s plus 1 into x1 of s. Now I am going to expand this term. So y of s is equal to minus 2s into x1 of s. Y of s is equal to minus 2s into x1 of s plus x1 of s. Now apply the inverse Laplace transform. So y is equal to minus 2 into x1 dot plus x1. And next we have to write instead of x1 dot, what is x1 dot? x1 dot is equal to x2. So already derived. So instead of x1 dot, you have to put x2. So y is equal to what? Minus 2x2 plus x1. Now write the output equation in a matrix form. So how to write this? Y is equal to, here you have to write the values. So x1, 1, x2 minus 2. Is there any x3 term? No. Put 0. Here x1, x2 and x3. So this is the state equation, the first one. And this one is the second one is the output equation. So in this way, we have derived the state model from the transfer function. Thank you. Have a nice day.